Hello. Hello, everybody. How are you doing? So, I'm very excited today to talk to you about the future of artificial intelligence, which I actually think is largely in natural language processing. We may get some slides in a second, or not. So, maybe I'll get started. Before I'll talk about we got a little ahead of ourselves. All right, cool. Before I'll talk about natural language processing, I want to tell you why we can now focus on language and not just on other modalities in artificial intelligence. And it actually started in 2012 or so with deep learning advances in computer vision. Until then, computers couldn't even tell the difference between a cat and a dog and an image. And there are a couple of really powerful ideas that have emerged over the last couple of years in AI. And the first one is supervised learning, having a lot of training examples for some kind of input that you're mapping to some kind of output, relatively simple. I'll go through a couple of examples of what these inputs and outputs could be. In the beginning, it was mostly images, and the output was what is the main object you could see in an image. And another really powerful idea that emerged in the last couple of years is end-to-end trainable deep neural networks. Cue epic sound effect. So we basically are able to give raw inputs to these AI algorithms, and we don't require human experts to design and say, I think a cat should have eyes here and whiskers there and a tail over there. You just give it raw pixels, and you ask, what is the final output that you want to predict from this image? Very simple, but very powerful ideas that allowed computers to see in just the last couple of years. Another huge advance that we've seen is in speech recognition. The input X here is actual audio, MP3s, simple audio files, and the output is what are the words that are being uttered. And it's pretty amazing what has happened in the last couple of years. We can already, with Siri for instance, talk to a computer and have it translate into written text. We can even transform speech now. This is a recent paper we just had accepted yesterday at Interspeech, one of the top speech conferences in the world, where we can translate male-sounding voice into female-sounding voice in order to make speech recognition work more accurately, even when you don't have as much training data from different groups of people. But what does that all lead to? Google gave us a little bit of a glimpse of something that I've been predicting for the last year or two, and that is that we can have a lot of service conversations with algorithms. And so I'll show you a brief video now on something that Google just released a couple of weeks ago. Let's play the video.
So how can I help you? Hi, I'm calling to book a woman's haircut for a client. I'm looking for something on May 3rd.
On the left side is an algorithm doing the talking.
Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like. What service is she looking for? Just a woman's haircut for now. Okay, we have a 10 o'clock. 10 a.m. is fine. Okay, what's her first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks. Great. Have a great day. Bye.
Thank you. So this is pretty incredible. The conversation on the left was done entirely by an AI algorithm. But that was only one specific domain, namely scheduling a hair appointment. But imagine this kind of technology basically becoming more and more powerful in the next couple of years and allowing a lot of different service conversations to be automated. And not just from the people who want to get an appointment on the hairdresser, but actually having the companies in the background using a CRM solution, knowing their customers, and then automating those kinds of conversation. But this looks a little bit too good to be true, and there's a reason it wasn't a live demo yet, because language is quite complicated, and there are a lot of complexities around it to make it work. We're getting pretty good when everything is relatively standardized, we're in a small domain, we're only talking about specific subjects. As we're more and more open, and we allow more and more colloquial language to come in, kids doing talking, and so on, it's actually becoming quite hard. Language, unlike vision, is something that humans make up. We create new words. You can have some kids say YOLO, and all of a sudden your algorithm needs to understand what that means. You only live once, you do crazy things. Or you say this cake is the bomb, and an algorithm might get very scared all of a sudden, thinks it's something about terrorism is going on, when really that's just a colloquial term for this cake is great. So, in fact, we can see natural language processing already in action for some pretty important subjects. This was an article from 2011, and things have changed since then, but to some degree, some things are still the same too. And that showed that whenever the actress Anne Hathaway, famous actress, got a couple of Oscars, whenever she stars in a movie, the movie reviews come out, and the reviews are very positive, then the stocks for the company Berkshire Hathaway go up significantly. And that happened multiple times in a row, where people basically realized there's semantic trading algorithms, automated trading algorithms running that do sentiment analysis, and whenever they say Hathaway, positive, they buy Hathaway stock. But of course, there are different kinds of Hathaways. We, in natural language processing, call that an entity disambiguation problem. They basically got the wrong Hathaway. Since then, we've made a lot of progress, and here are a couple of examples that we can now accurately classify the sentiment of. And they're particularly interesting because it's those kinds of examples that even just 5-10 years ago, every algorithm in the world that was completely trained would have gotten completely wrong. The first sentence is, in its ragged, cheap, and unassuming way, the movie works. So despite the movie being, there being words like cheap in that sentence, it was still a positive sentence. Or the other one, the best way to hope for any chance of enjoying this film is by lowering your expectations. Again, an example where you have a lot of positive words like best and hope and chance and enjoying, but you only get to these positive things if you lower your expectations so much that you would have fun in this movie. So even those kinds of complex examples we can now accurately classify. What's even more exciting is in what's happening in machine translation, because machine translation has a lot of inputs X and outputs Y. We have a lot of very large training data sets where we have a source sentence in one language, like German, and a target sentence, the translation of that sentence into English. And because we have a lot of these parallel corpora, we can train very, very accurate machine translation algorithms. And we can even do this in a fashion now that's completely parallelizable. So you can actually, in parallel, go over, should be playing a, I see it on my screen, but you don't see it. You can completely in parallel now translate sentences from one language into another language, which is pretty incredible. Like basically, you can translate all the words of a sentence that you can't unfortunately see on the right side here in German, and translate the third word in parallel to the fifth word and the first word and so on, without knowing what all the other words are. And that will allow us to reduce this latency of machine translation systems to a point where we can essentially build a Babelfish, where you can have a little button in your ear that will live translate when somebody talks to you. Now, another recent advancement in natural language processing is in summarization, where we actually have a long document. We all basically have to go through a lot of emails every day, a lot of news, and summarization will essentially allow us to take only what's the most important content of a document and then read that summary. And in the last couple of years, we've seen an amazing progress. Here you see a summary of a longer document, and that summary is completely trained without people telling you what the important facts are, how to identify important facts from documents. Again, the takeaway message here is if you have hundreds of thousands of input documents that are very long and they're summaries, you can train an AI algorithm to automatically generate those kinds of summaries for you. And the interesting problem for you is what in your industry are the examples of X and Y that you have to automate a certain kind of process. This is the first time, and this paper is just from last year, this is the first time that an algorithm has been able to generate multiple coherent sentences that are completely trained based on just training data. The algorithm has not been given any information how to identify what the important facts are in a longer document. Another great example is in question answering. In fact, question answering I think is one of the most interesting tasks that we will need to get better at if we want to really accurately have chatbots give us more complex answers that aren't just scripted. So in the example you saw from Google, it's a very scripted kind of problem. You ask for the hair appointment, if it's available, you book it, if not, you go down a decision tree. But in some cases, you might ask a question that requires actually a pretty complex reasoning step where you have to go into a knowledge base and really reason over multiple different facts from, for instance, a customer story and so on. And in this case here, the answer of why was AC electricity gaining popularity is actually a phrase somewhere in this knowledge base or somewhere on Wikipedia. And a last application that is very important too is question answering over an actual database. A lot of data that is important about your customers is stored in databases. Here, my research group has developed an algorithm that can translate from English into SQL queries, database queries. So now, even business users that don't program, that don't know how to program a database, can ask questions and actually get answers from basically running some complex reasoning steps over a database. Again, lowering the bar for what you can do, and also lowering the bar for the knowledge that is required, empowering you to do more. And it's all these kinds of algorithms that if we want to have a chatbot, like the Google Duplex one, that can answer all kinds of different questions, these are things that we all need to integrate into such a chatbot. And in order to integrate that, we actually have to either build a very complex system, or research has to push a little bit further and try to build a single algorithm that creates and has the ability to answer very different kinds of questions. And that is, I think, the next frontier for the field of NLP and something we're actively working on, and that is multitask learning. Having a single algorithm that can answer all kinds of different questions. Here are a couple of examples of what that would look like. We've essentially built a single algorithm that can answer lots of different kinds of questions and solve over 10 different natural language processing tasks, all within a single model. And what that would allow you to do is essentially have a much simpler deployment and will basically empower every single company out there to solve different kinds of NLP problems. So you won't require a multi-billion-dollar research budget if you have a complex natural language processing problem that you want to see solved. What you can see here is that we essentially cast every different one of these NLP problems that I described to you before as a question answering problem over some kind of input document. And when you have, for instance, the question, to whom did the Virgin Mary appear, you have some long context document, it extracts the answer for it. But you can also ask, what is the translation from English to German? And that's yet another question answering problem that this same model can solve. You can ask, what is the summary? And you can see all these different problems are essentially question answering problems over some kind of input. And now that we have a single model, we essentially have a Swiss Army knife for natural language processing. And that will allow us to generalize all these different questions in a way that this model will even be able to answer questions it's never seen before. In fact, we've asked this question, a simple news story. John went to his birthday party, nobody showed up, he was all alone. And we asked the model, is this story happy or sad? The model had never been trained to classify happy or sad stories, but it still got the answer right. And so these kinds of zero-shot learning capabilities will be really powerful when we combine that with a knowledge base about customers and then essentially automating all kinds of service interactions where we have a single model underneath it that can translate, that can summarize, that can ask questions and answer questions, and understand also the sentiment. Because in the end, whenever a chatbot conversation doesn't work, you might still want to escalate it to human. In the end, we want to empower humans to only have to focus on things that aren't boring and repetitive, but are actually requiring some kind of more complex interaction. And with that, I want to thank you for your attention. I'll actually give another talk tomorrow where we'll be a little more high level. This was a deep dive session into natural language processing. Thank you.